Okay guys, back here in the office in Mundelein talking about this Haas VF4 Super Speed we have behind us. So, you know, to put some extra set of hands on it, as we call the tender, we had to do a few modifications. And we added some things like an auto door, we added some things like a grid plate on the table, we added one of our excellent Nikken tilting rotaries. We also added some vices and some other things on the table. The other part of it is we had to do some modifications to the electronic circuits. We had to make an extra door switch, a few things like that. But I'm going to walk through these one by one for you. Let's start with this grid system though, because I think this is worth mentioning. So when we evaluate an opportunity for automation, one of the things that we look at straight away is how far along is the customer in their lean journey, right? If they're still using some six-inch vices, you know, two of them on a 20 by 40 mil, they're probably a little bit of ways off, okay? Nothing wrong with that. That's how we all get there. We start with that and we work our way through it. But if you see a customer that's using a receiver system on the table, whether it be something like Ball Lock from Juergens or M-Power or our friends at Chick have some nice foundation plates. You know, there's a lot of ways to skin this, but if you see someone that's starting there, you know that they're halfway down the road with you. So now the next piece is what do we have that sits on top of that that can be controlled via air or oil, okay? In our case, we're using a Juergens ZPS system that is fed air through a rotary union that is built into our 5AX201 on the tilting axis, and then we have another rotary union coming up through the bottom of the rotational axis to feed air up there. So all of that's pretty cool, but we got to start with some kind of foundation, some kind of fixed positions on your table. So I just show you guys this Ball Lock system, which is great. It's been around since about 1979. It's super. You put this in between, you put this through your fixture plate and down into your sub plate. One screw expands the balls out, locks your fixture plate on location. 5/10 repeatability, hard to beat. Okay, some would say, well, I cover my table now. How do I machine my fixture plates? No problem. You use these extended shanks and these little spacer washers which go underneath your fixture plate. You come down through the top of your fixture plate, through the washer and into your sub plate, and now this thing's up off the table. Now you can machine your fixtures. Okay, so now we set the table, we have the foundation there. Let's throw a rotary on there. What a treat it would be if you could take your rotary with 4 pins, put it on your table, lock it down and be done. How many of us have spent those couple hours indicating this axis in, that angle in, all that kind of stuff? We all been there, we know how it is. What a treat it would be just to do 4 pins and you're done. Pretty cool. So that's the big part of this, is that foundational system. What have we done to make that happen, right? So then we look at the rotary axis. Now the rotary axis, whether it's a tilting rotary axis in our case behind us, or it's just a rotary axis, is a major force multiplier for you. Envision, if you will, if we had a box that is mounted to the face of your 4th axis, supported by a tailstock out here, and you could put work and work holding on all 4 sides of this box. Think of the productivity you can now get out of your vertical mill. It's almost like having a horizontal, but you didn't pay the bill, right? It's pretty cool. Now let's accelerate that even further. Let's throw a tilting rotary axis on there, give you 5 axes. Now all of a sudden your 3-axis machine is a powerhouse, okay? And think about this. What if I could find a system that could load it and unload it repeatedly all day long, throughout the night, throughout the next morning, and so forth? Wouldn't that be a treat? Well, that's what that extra set of hands from the tender does for us, okay? And then we got to talk about, well, somebody's got to open the door, right? Well, how do we do that? Well, we got to get an auto door system, right? Many of the major manufacturers of machine tools have a factory installed auto door, okay? In our case behind us, we bought our machine with the auto door on it. But let's say you don't have that auto door right now, not a showstopper. Plenty of off-the-shelf aftermarket options that we could throw on the front end of your machine to open and close your doors. Maybe you need to go through the side of the machine. That's not a problem either. Plenty of options for that as well. Now that we're inside the machine, the door's open, we're ready to land something. What's the receiver system? What do you want to use? Well, if you're like most shops, you have a smattering of a little bit of everything and you use, what's there, right? But if you ever start to get serious about your automation, you really need to think about what provides you the biggest bang for the buck, what's the most economical, and you got to start to think about which one works the best, okay? We have used multiples on our 2 machines here in the office, and we found great success with all of them. All have their pluses for sure. So it's really up to the customer on how they want to approach that, okay? Some of your options would be the Jergen 0 Point, the Schunk Vero S system. You have Fifth Axis has a really nice system for their rock lock pallets. There's some stuff from Aroa. There's some stuff from System 3R. Tons of options out there. There's some new stuff on its way out from Pearson Work Holding. So lots of options out there, guys. And then really the other thing that we did with our machine is we had to make some simple G-code programs that would tell our robotic interface, hey, it's your turn to act, right? And the nice thing about working with a company like Haas, they have a really nice system for that allows you as a third party or an owner to be able to attach to the system and be able to manage self-save signals and door open, door close, things like that. Is your work holding clamped or unclamped? A lot of cool stuff you can do on your own, on the cheap. It's really pretty neat. And then lastly is this, you gotta verify your handshaking, right? Because this guy over here, this tender, it doesn't tell the machine what to do, and the machine doesn't tell it what to do. They work in sort of this symbiotic relationship. They wait for a signal to say, okay, it's your turn. Then that party does its job. Once that work is done, we want to verify that work's completed. Once we know that work's completed, then the next party starts to do their function. And we keep running through this cycle. We call this handshaking, right? We're handshaking. So we want to be able to do that and verify what's happening on the machine tools. So there are a few things that you have to think about when you look at attaching tending system to your machine tool. 1, what's your grid system? 2, what's your receiver system that you want to deal with? What's your auto door options? And then how easy is it to handshake with another device? So take those things into consideration when you're taking a look at this. And once you get to know the tender a little bit, you'll find out how easy that really is. Okay, so let's jump inside the safety cage and take a look at the star of the show, which is our Fanuc M20i Delta robot outfitted with a Schunk Mini NSR end of arm tool out on the end there. The nice thing about this robot and its application bandwidth, it has the capability of allowing all kinds of different cabling, whether it's electronic or pneumatic, to go up through the center hole to provide power or utilities to the end of arm tool. So we have a lot of options that we can exercise in that regard. This is a nice, sturdy industrial platform that is IP rated for the industrial environment. It'll tolerate the coolant, dust, all of those kinds of things. It's a really nice system. A great pairing to the tender. Hey, thanks for joining us for the video on the tender. You know, we're super excited about this product, new to the market, had a lot of options we could exercise with this. So we hope you join us for the rest of the series on the intro to the tender. But beyond that, we have plans for a whole video series on applications per industry, such as things like general purpose or general industry, firearms, medical, aerospace, tool die, mold, things of that nature. Super excited about that series. And in those series, you're going to see things like how we develop the process, what CAM system we use to make the program, and we're going to use several just to show you the differences so you can apply it to what you guys do in your space. And then once we're done with that series, the next up on our target list is to do a series that talks about the different types of shops. Are you a job shop? Are you a product shop? Are you a contract manufacturer? And we want to do some application studies based on those environments. So you're going to see a whole mix of things as it relates to the tender and how it can be applied to solving your biggest problem, which is unfortunately this lack of labor today. Think of the tender as that extra set of hands.